Hi, and welcome to our first section in PreCalculus, section 2.3. This is on linear equations in two variables. Sections 2.3, 2.4, and 2.5 are all hopefully review for most of you. If you need any help after you go through these videos, remember you can always email me. We can set up a time to discuss anything you still might be having trouble with, okay? All right, so your job is to fill in these notes along with me as I go through, so hopefully you have them printed out. And we're going to get started now. So this section specifically is on linear equations in two variables. The two variables we're going to be working with for most all of these are x and y. So the first thing that you need to be able to do is pick out if you have a linear equation or not. So up at the top, the first definition says that a linear equation is any equation that can be written in the standard form shown below. So we're going to fill that in. So if you remember anything from your algebra days, the standard form of a line is the equation ax plus by equals c. Okay, that is your standard form for a line. And remember that a, b, and c must be integers. Remember that an integer is a whole number, positive or negative. Okay, so these numbers a, b, and c have to be whole numbers, and they have to be positive or negative, except for a. Right here, remember that a has to be a positive number. Okay. So a has to be positive, b and c can be positive or negative, but all three of those have to be whole numbers, integers. All right, so here are some things about writing this line in this form. X and y always have to have an exponent of 1. Okay, so you remember you don't see the exponents to the first power. X and y cannot be multiplied together. And x and y are not in the denominator, they're not in any exponents, and they're not under any radical signs. Okay, so they have to be strictly by themselves, separate, and always to the first power. All right, so underneath here we have just some examples for you on what a linear equation might look like in different forms, and then what's not linear over here. Now these are not all of them, okay? These are just examples of a few. So obviously this first one is linear because it is already in standard form. The second one is linear. It's just not in standard form, but we can take that and rewrite it over here, and that is in standard form, right? There's the x, there's the y, and there's the number. Same thing with this one. It's not in standard form yet, but we could write it in standard form here. Okay, so that's kind of a guide for you that when you're trying to pick out is something linear, you could take the time to write it in standard form, but if it's just asking you, is it linear, then you just need to know that you could get it here, okay? Not necessarily that you have to write it that way. All right, here are some things that would definitely not be linear. You wouldn't even have to do anything. So the first one, since I see this x times y here at the front, that cannot be a linear equation. That's a different kind of graph. The next one, x cubed, can't be linear because x has a different exponent other than 1. And then this one, I see this y is in the denominator, so that can't be linear as well. Okay? All right, so our first three problems underneath here are asking you to determine whether or not each of these equations is linear. And if it is linear, then we're going to write it in standard form. All right, so looking at number 1, okay, I'm going to try to see if this is linear or not. So just looking at it, I do believe this would be linear because I've got a 3x here, and even if I multiplied the 7 through here, I would have a 7y and a negative 7x. So those are all separate things. So this is a linear equation. So I can write it in standard form. Okay, so in order to do that, I do have to multiply the 7 through here and use my distributive property. So I'm going to do 3x plus, and then I'm going to multiply 7 times each of these terms. So 7 times y is 7y. And then I got a positive 7 times negative x, so that's going to be negative 7x equals 10. Then I can add my like terms, so I can add the 3x and the minus 7x to give me a negative 4x plus 7y equals 10. All right, so I'm almost in standard form. I've got all whole numbers, but I can't have a negative x. Remember that a value right here has to be positive. So if you start with a negative number for the a value, then you simply multiply everything in your problem by -1, which remember just changes all the signs. So that would end up giving you 4x minus 7y equals -10. So that would be the standard form. And so yes, this is linear. Okay? All right. Number 2, I don't even have to do anything because I see this multiplication here of x and y. As soon as I see that x and y are multiplied together, I know that cannot be linear. So this is not linear. Okay? So I don't have to go any farther. There's no way to write that in standard form. All right, the last one. All my x's and y's are separated. I don't have anything in the denominator that's a variable. I have no variables multiplied together. So this is a linear equation. So now my job is to write it in standard form. So the first thing I'm going to do, since we don't like fractions of any sort, remember if you have a number in the denominator, we're simply going to multiply this number to the other side. So I'm going to take that 2 and multiply it over here to the left. So that'll give me that equation. Okay, so I multiplied this denominator over here. All right, now I'm going to distribute. So that would give me 4x minus 6. 2 times 2x is 4x. 2 times -3 is -6. Okay. All right. Now I have to move my x term over here. I need to move, well, actually, I'm going to rewrite this. I'm just going to switch this around for you guys, okay? And how you solve this is totally up to you, but I'm just thinking of what most of you would probably do. So since I have the 7x plus 5y, I'm going to put that on the left, and I'm going to put the 4x minus 6 over here. So I'm just switching around the equation, right? I didn't change anything. I just wrote it differently, okay? All right, so now all I have to do is take this 4x and move it over here with the 7x. Because remember, standard form, all the x's have to be first. So I'm going to subtract this 4x minus 4x over here. So 7x minus 4x is 3x. And everything else stays the same. And that is standard form already. I've got a positive a, b and c are integers. So there's my standard form. And we did say that, yes, that was a linear equation. Okay? All right. Next on our page is horizontal and vertical lines. It's one thing that students get confused on, not necessarily that you can't pick them out, but sometimes you make the mistake and switch them around. So, horizontal and vertical lines. Okay, the equations of any horizontal and vertical line are missing one of the two variables. So when you see an equation that just has y equals a number or x equals a number, then those are your horizontal and vertical lines. Okay, so you just have to remember which is which sometimes is a problem. So determine if the following represents a horizontal or vertical line. So for number 4, all equations that have just a y in them, y equals 5, those are your horizontal lines. And then number 5, any equation that just has x in it and no y, those are your vertical lines. Okay? So it's easy to get these mixed up. And I think for most students, if you just kind of remember your axis, right? This is your x-axis, and then this is your y-axis. Didn't mean for that to be okay, so typically you guys remember that x is your horizontal axis. So when you see x equals, you tend to think that's your horizontal line. Remember, that's opposite of what you think, because when you look at x equals a number, then that means you got to go to this axis and go to -2. Well, x equals -2 is right there, right? That's where x equals -2. So if I'm going to draw a line through -2, that line is going to go this way. It's a vertical line. That's x equals -2. Basically, that says no matter what y is, x is -2. Okay, so no matter what the y value is, I'm going to go to x equals -2, which is right here. Okay, so you wouldn't draw a line this way because that would just be the x-axis. So that can't be right. So it's always opposite of what you think. Same thing over here. If I want to go to y equals 5, I would go to 5 on the y-axis, right? Right up here is 5. So y equals 5 would go this way, would be horizontal. Okay? So you just kind of have to remember it's opposite kind of what your brain is telling you the x and y axis looks like. All right. We'll do a few more of those. So, all right, on the next page then, let's look at what's coming up. We've got x and y intercepts. Again, all of you guys have done this probably since your pre-algebra days, so hopefully this is just a quick review and you get through this these homework assignments pretty quick. All right, the x-intercept, remember, is where the graph of an equation crosses the x-axis. And to find the x-intercept, remember that you always let y equal 0. That's how you're going to solve. And then the y-intercept is where your graph would cross the y-axis. And to find the y-intercept, you always let x be 0. And then you solve the equation. Okay? All right, so let's look at a few of these. We're going to find the x and the y-intercepts if we can. Sometimes there is not one, so we'll look at that. And then we're going to graph the equation by plotting those two values. All right, so let's start with the x-intercept. Okay, so we're going to find the x-intercept. So to find the x-intercept, remember we're going to let y equal 0. Okay? All right, so here's our equation. So to find the x-intercept, we're going to let y equal 0. So 6 times 0 minus 3x equals 18. So anytime you're letting that y value be 0, 6 times 0 is 0, so that term's always going to go away. So we're going to end up with negative 3x equals 18. Divide both sides by negative 3. So you get x equals negative 6. So the x-intercept, sorry about that, x-intercept would be negative 6, 0. Okay? All right, so I'm going to come down here to the graph, and I'm going to plot negative 6, 0 right here. So there's your x-intercept. Okay? All right, back to the equation. Now we're going to look for the y-intercept. So remember, to do the y-intercept, you're going to let x equal 0. All right, so that means I'm going to put a 0 in for x. So that's 6y minus 3 times 0 equals 18. So again, that's going to go away. 3 times 0 is 0. So we have 6y equals 18. Divide both sides by 6. We end up with y equals 3. So the y-intercept would be 0, 3. Remember, ordered pairs. Okay, so remember, x-intercept, we found x, we let y be 0. And on the y-intercept, we let x be 0, we found the y-intercept. So make sure you put your ordered pairs in the right order. All right, so the y-intercept would be at 3. And remember, all you need is 2 points to graph a line. So that would be where your line is. Okay. So there is the line, 6y minus 3x equals 18. Now, going back to what we just did on the page before, that is a linear equation. It's not in standard form. Okay, so standard form, I would have to move these two guys around, and then I can't have a negative x. So I'm going to take this down here just to practice. So 6y minus 3x equals 18. Slide that up a bit so you can see it. All right, so there's that equation. If I had asked you to put that in standard form, first thing I would do is put the negative 3x in front, the 6y second, and then that 18. And then I would multiply everything by -1. So my standard form would be 3x minus 6y equals -18. Okay, so they're the same equation, it just depends on what you're asked to do. Now I know this didn't ask for that, but I like to do that with this one because that's important that you see that it's not standard form. Okay, one other thing for those of you who kind of struggle with the signs, when I teach, I always tell my students that whatever the sign is in front of each term, that's the sign of the number. Okay, so when I look at this problem and I see 6y, then I know that 6 is positive. Since it says minus 3x, I know that the 3 is negative. Okay, that means the same exact thing in math. So that's how I look at it. So some of you I know like to do plus and a minus, plus and negative. You don't have to do that if you just remember that that's the sign of the number. Okay? All right, moving on. Number 7. All right, let's do x-intercept. Okay, remember we're going to let y equal 0 for the x-intercept. Okay, so if we let y be 0, we're going to get -5 times 0 equals 20. We end up with 0 equals 20. Right? There's no x in this problem, so that's not a true statement, that's false. So there would be no x-intercept. Okay, no x-intercept. All right, for the y-intercept, we're going to let x be 0. Well, there's no x in this problem to worry about, right? So I'm just going to solve that for y, since I don't have an x. So I would take -5y equals 20, divide by -5, you get -4. Okay? All right. So if y equals -4, remember what we said on the page before. If one of the variables is missing, that's either a horizontal or vertical line. So let's do what we said before. We're going to go to the y-axis and go to -4. Okay, so 1, 2, 3, -4 right there. Y equals our horizontal lines. Okay. So look at that and then look at what we found. There was no x-intercept, obviously. Doesn't cross the x-axis anywhere. And the y-intercept is definitely that point at -4 because the y value is always -4 in this problem. Okay? Now, did you have to go through all this? Not necessarily. Hopefully, once or depending on how well you remember linear equations, you know that that's already missing the x value. So, you don't need to go through this, but just showing you just in case you do, that's what would have happened anyway. All right, let's look at number 8. Okay, so we're going to start with looking for the x-intercept. So to do the x-intercept, remember you want to let y equal 0. This one does have a y in it, so we can do that. So 4 minus 3 times 0 equals -20 minus 8x. So again, 3 times 0 is 0, so we've got 4 equals -20 minus 8x. All right, so now we've got to solve for x. So let's take this -20 and move it to this side with the 4. So remember, anytime you take a number and move it over the equal sign, you're going to do the opposite. Okay, so since I have a -20 over here, when I move it to this side, it's going to become a +20. So 20 plus 4 would give you 24, and you still have a -x on the right. We're going to divide both sides by -8, so we end up with x equals -3. So your x-intercept is -3, 0. Okay, so go down here, x-intercept, 1, 2, 3. Right there is your x-intercept. Okay, and then your y-intercept y-intercept for this problem, we're going to let x be 0. All right, so we're going to let this value right here be 0. So we're going to have 4 minus 3y equals negative 20 minus 8 times 0. Okay, so again, that's 0. And you can leave this step out. I'm just showing you. But always you're going to have that term be 0 when you're letting x or y be 0. So we're at 4 minus 3y equals negative 20. All right, this time now be careful with your signs. There's a positive 4, right? This is a positive number. We're going to move it over to this side. So when we move it over, it's going to become a negative 4. So that's negative 20 minus 4. So that's going to give you negative 24 on that side. And right here, we're ending up with negative 3y. Divide both sides by negative 3, and we'll get a positive 8. Positive 8. So your y-intercept would be 0, 8. Okay, so we're going to graph that. And that would be our line. Okay? All right, so those are your x and y intercepts. Now, I'm going to go back to this middle one because I just didn't write it. But over here, your y-intercept would 0, negative 4, right? That's how you would write it, the ordered pair. Okay. All right, so again, most of you don't have any problems with doing that. What I find that you have problems with is watching your signs and losing negative signs and so forth. So just please be careful when you solve. I know for some of you it may have been a while since you've done this and solved equations, so just make sure you're taking your time and practicing with all your, don't be careless with your computations. All right, last thing for this section is graphing a line by just any 2 points. Okay, so you could do the x and the y-intercepts, but you do not have to, so it's totally up to you. All right, so the way that your book shows this is just picking some points. Okay, so I'm going to do this by doing a table. All right, now, the easiest of all points is the y-intercept. Let x be 0 and then solve for y, right? So we're going to do that. We're going to pick 0 for one of our points. All right, and I'm going to come over here to the right and I'm going to let x be 0. So y equals 0.25 times 0 minus 2. So that is the y-intercept. So 0.25 times 0 is 0. So we end up with y equals negative 2. So there's an ordered pair, 0, negative 2, down here. Okay, that is the y-intercept. Now, do you want to pick y equals 0? Well, you could, but since this problem is solved for y, I really don't want to pick that because that's too much work, I think, to involve. I just want to pick another number for x. All right. Since I have a decimal, 0.25, I don't want to pick just any number. I want to pick numbers that are going to be easy for me to solve. Okay? So I want to look at something that would go into that evenly. So instead of writing it as 0.25, I hope most of us know that 0.25 as a fraction is 1/4, right? It's the same problem. 1/4 of x is 0.25. So now I can see that I want to pick numbers that 4 goes into. And that would be the easiest thing to do. So I'm going to let x be 4. You could let x be 8, right? Anything that 4 will go into. And I'm only doing this so that I don't have fractions. Now, if you're going to use your calculator, you can pick any number you want to and let your calculator help you compute that. Since I'm not using my calculator right now, I want to pick numbers that make this easy for me. All right, so I'm going to let x be 4. So 1/4 times 4 minus 2. Okay, so 1/4 times 4 is 1. These 4s are going to cancel out. So that gives me 1 minus 2, which is negative 1. So there's my next ordered pair, 4, negative 1, which would be right there. Okay. All right, so there's my line. Looks like that. Now, we'll get into doing this on the calculator and showing you guys some things. I don't want to do it right here because these are very basic and I think you're okay without it, but by all means, you can use your calculator on all your tests, on the exam, so you're fine if you want to plug these into your calculator as well. Okay? All right, and the last one on this notes, this one where you're plotting some points. All right, if I look at this 2x equals -8, hopefully you're saying, oh, there's no y there, so that's either a horizontal or a vertical line. And since there's just an x in this problem, that means it's a vertical line. But if you're asked to pick two ordered pairs, when you do your homework, you're probably going to have to plot two ordered pairs. Okay, so again, pick some numbers for x, okay, and see what happens. So if I take 2x equals -8 and I divide by 2, I get -4. So I know this is a vertical line that goes through -4, right? So there's a point right there, -4, 0. Okay? All right, but it's a vertical line. Okay? There's no y value for me to evaluate anything. So I know that this line looks like this. So this is a good opportunity for me to explain what I said earlier about vertical lines. No matter what y is, x is -4, right? So I could pick anything. I could say, all right, if x is -4, y is 7. Well, look where that is. -4, 7 would be right there. Okay? If x is -4, y could be -2, right there. So it doesn't matter what you pick for y, because x will always be -4. That's what vertical lines are telling you. Okay, so I could pick anything for y, doesn't matter, x will always be -4. So all the ordered pairs you're picking have the same x value right there. Okay, so hopefully that kind of shows you why those are vertical lines and not horizontal lines. X has to be -4. All right, so I picked 3 points. You only needed 2, but that's how you would do those. All right, so that finishes up the first section, 2.3. So remember the way the class is set up. Your job after you get these done is to try to get your homework done as soon as possible. I know you have a couple days that it's not due on Hawks, but to your benefit, you should do your homework as soon as either today, at the latest tomorrow, because you cannot get behind in this class. You got a lot of sections to do on a weekly basis, and if you push yourself and wait till those last days to get homework done, you're going to get yourself in trouble as we move into some harder materials. So work on your homework today sometime or tomorrow so that you can begin the next section in a day or two and know that you're already completely done with this one. Okay? All right, so you guys have a good day. I'll see you back here for section 2.4. And again, always remember, email me if you have any questions. Okay?